This is the Newton's second law lab, lab number 11. Okay, look at how acceleration is affected by the force and the mass acting in a system. We've got an air track right here to do that, a smart pulley on one end to measure the velocity of the glider. We've leveled the air track to make sure that it's only going to be accelerated by the string itself and not by gravity. We've got to first measure what the mass of the system is. We have to measure the mass of the glider, the hanger, the string, and the 195 grams of mass that we have in slotted masses. In this lab, we'll keep the mass constant. We'll transfer mass from the glider to the hanger so that the mass of the system remains the same, as we're simply changing the force acting on the system by adding it to the hanger itself.
382.83 grams.
82.83 grams. And mass will remain constant for the first part of this lab, which is the constant mass part, part A. Place that back on the air track. Of course, turn on the air blower to get a nice frictionless or close to frictionless glide. And we'll see what the acceleration is. To find the acceleration of the system, we're going to use Logger Pro, which will plot a velocity versus time graph. We'll then find the slope of that velocity versus time graph to find what the acceleration is. Here we go. I'll click on Collect to gather the data, and now great day, as you can see over here. I can click and drag a box around the central portion of that data. Click on the linear fit button up top, and it tells me the acceleration is 0.2531 meters per second squared. 0.2531 meters per second. It's a linear fit, a nice straight line there. Slope of the line being the acceleration. I'm going to do it again now. Ready and go. Got another graph. Ignore all of this stuff. That's after it hit the thumb. We're going to click and drag a box on this nice linear portion of the graph. And we've got 0.2518. Very similar to our last reading. We'll make 3 trials of each mass and find their average. Now we're going to change the mass. We'll do one more trial first, but then we'll change the mass by taking 2.5 grams off the glider and putting them onto the hanger, so the total mass of the system still remains the same. And the force on the end has been increased. And we'll try it one more time to see what happens to the acceleration. And go. There we are. Click and drag a box around the data. And now it's 0.5023. Significant change. It looks like it's been pretty close to being double from what it was before. After we finish taking all the data, we're taking data for 1, 2, 3, 4, 5, 6, 7, 8 different runs at 3 trials each, 8 different masses of applying the force to the system. For 3 trials each, we'll go to part B, which is going to be the constant force part of the situation. Now what we'll do is have a constant force on the hanger itself, and we'll keep adding masses to the glider and see how that works. This was done using interactive physics, which is a simulation program. It produces ideal data, subtracting out any frictional effects, but gives us also a data table of the accelerations, which we can then plot. All right, here is our air track, drawn with our interactive physics program, and not here it will do its calculation what the acceleration is going to be. Let's hit it run. Looks like the acceleration with this first trial is 0.467 meters per second squared. Then we'll click on the box and add to its mass. keeping the force the same here on the end, and click on the box and add to its mass. Right now the mass is 0.4 kilograms. Let's make it 0.6 kilograms. We'll run it again. This time the acceleration is 0.316. We'll reset it. We'll increase the mass again to 0.8 kilograms. And now the acceleration is 0.239. Of course, the acceleration is decreasing as the mass increases. Now, there's no need to do 3 trials on this. It's simply making an idealistic calculation, so we can just run it one time each time. It's not going to vary because the computer always spits out exactly the same number, no matter how many trials you run. We'll provide you all the data that for this particular